If a spring is taken like this, I am taking an ideal spring, okay?
Yes, sir.
Yes, sir.
If this ideal spring, it has, this is called as natural length, okay? Then, if in case you extend it, if you extend this string
Yes, sir.
with an extension entirely x distance, so, and the string will become L plus x, okay?
Yes, sir.
If you compress it by x distance,
L minus X.
L minus X.
okay, L minus, now when you are expanding it to x distance, but for by x distance, the spring resists any extension or compression, okay?
Yes, sir.
Spring resists any expansion or compression. So what will happen? Spring wants to retain its original position, wants to come back to its original position.
Original position.
So there will be a force which is equal on both sides. Ideal spring, the force will be equal on
Both
both
sides.
sides.
Yes,
Like
both.
ideal string, that entire string will have tension T, isn't it?
Yes,
Yes,
sir.
sir.
Cut it and pull it. Here also tension will be T, here also tension will be T.
Well,
Okay, like
okay,
this. Here the spring force will be Fs. The left side string it will try to tell me, Ujjwala.
Sir?
Did you ask me question?
No, sir, I didn't.
The spring force, like this end and this, that other end also, the force will be Fs, equal force for an ideal spring,
Okay, sir.
which is actually
Okay,
massless,
sir.
light spring. If it does not mention anything, you take it to be light spring, ideal spring, and which has force equal on both sides.
Yes, sir.
It will try to compress with Fs here and it will try to compress with Fs here, both the sides. Did you understand this?
Yes.
Yes, sir.
Now, it is compressed. This third spring, first, second, third spring is compressed by x distance. So it wants to go back to its original position. That is why there will be a spring force which is trying to relax and come back to its original position.
Position.
So the direction of spring force, did you understand? Here you expanded it, it wants to get compressed. The spring force will be towards inside. Here you compress
Yes.
it, the spring force will be towards outside. Did you get Varun?
Yes, sir.
Now, experimentally, you don't need to find out the derivation of it. Experimentally, this is found to be that spring force is proportional to
X.
x, the displacement that you do from its original position.
Yes, sir.
So that spring force is equal to some constant into x, that we call it as k. That
K.
I'll take it as k. That is called as
Spring force.
spring constant, or take another name,
Stiffness constant.
stiffness constant.
Constant.
But in textbook, sometimes you will find out the spring force to be.
Minus.
What does this minus indicate is, see, if you displace, if I'll take this to be original position, okay? So I displaced the spring in the right side direction. The spring force is in which direction?
Left side.
Left side.
Left side.
That means if the displacement is positive, spring force is in negative. Here,
Negative.
Oh, okay.
here the displacement happened in which direction? Negative direction. The spring force will be in
Positive direction.
positive direction. So here also,
Yes.
the displacement happened in negative direction. So the spring force will be in positive direction.
Positive direction.
Here the spring force, the displacement happened in positive direction. So spring force will be,
Negative direction.
that means in books, whatever it mentions here, minus kx, is this minus symbol is indicating opposite to the direction of in case if you directly take the direction from your common sense, you can do that. If it is expanded, the direction you will be knowing or not.
Yes, sir.
So if you take
Sir.
the direction by common sense, don't use this minus formula. Directly use kx formula for the spring force.
Okay, sir.
Okay,
Okay, sir.
Varun?
Yes.
If
Yes, sir.
in free body diagram, if at all you have taken the direction properly, you don't need to use the formula minus there.
Yes,
Yes,
sir.
sir.
Directly kx we can take.
Yes,
Okay.
sir.
Then
Okay.
will you solve a question?
Okay, sir.
Okay, sir.
Okay. There is a 2 kg block. There is a 3 kg block. The spring constant is 100 Newton per meter. The displacement is 0.1 meters. It is displaced by 0.1 meters. And then what is the, find the acceleration of each block. Find the acceleration of each block just after release. Just after release. Why I ask it just after release is, after some time there will be different accelerations. Immediately that force will be there. After that, compressions will change or not.
Yes, sir.
After the spring comes to
Yes, sir.
motion, the compression expand. It will compress first, then expand, compress, expand. So you cannot find out the acceleration. That will be variable.
Yes, sir.
But just that's why I
Yes,
asked
sir.
it here. Just after the release, 0.1 meters you expanded. Just after release, what are the acceleration of the two blocks?
Okay.
Did you
Okay.
find out?
No, sir. Explain this one.
Okay. So I expanded 0.1 meters means, so what will be the direction of spring force? If I draw the free body diagram on 2 kg block, one will be 2g. It doesn't matter here because it will oscillate only in x direction, normal reaction.
Yes.
Okay? That I'm not taking into consideration. N is equal to 2g here. Okay. Other force is what?
Yes, sir.
It is expanded means spring force will be in which direction?
Right side.
Right.
Varun, you tell me.
Right, sir.
Right side. It's expanded. That means it has expanded to left side. So the spring force will be in the right side direction. Okay.
Right side.
Yes, sir.
Yes, sir.
3 kg block.
3 kg
Again,
block will
3g
have
and
3.
n is equal to 3g. Then another part is what?
Spring force will act in left side.
Left side
Left
direction.
side.
Okay. Got it or not?
Yes, sir.
What is that magnitude of spring force I told you? Direction you took properly. So now you don't need to use minus. So what is the magnitude
Yes, sir.
of spring force?
Fs is equal to kx.
kx.
Okay.
So what is
10.
k here? 100
100.
x
0.1.
Newton per meter. You carefully see the units also here. Into meter. Meter cancel. The answer will be
100 newtons.
10 Newton.
10
10
Newton.
10
newtons.
Newton.
So force you got on 2 kg block and force you got on 3
equal to
kg block. So acceleration is what? Acceleration of 2 kg block is what? Force by mass or not?
equal to ma. Okay, yes sir. Yes,
Force
sir.
by 2. The F is equal to ma here. Net force is equal to mass into acceleration. Same concept. I'm not using anything
Yes.
new. F net force is equal to mass into acceleration. F net force is how much here? 10 newtons. That is equal to mass of 2 kg block. That is 2 into acceleration of 2 kg block. That is equal to how much? 5 meter per second
3
square.
meter per second.
Similarly, acceleration of 3 kg block is equal to. Varun, are you getting this or not?
3.3 meter per second.
Varun? Varun,
Sir.
are you getting this or not?
Yes, sir.
Net force is 10 newtons, that is k into x, that is equal to 2 into acceleration of 2 kg block, 3 into acceleration of 3 kg blocks. So 10 by 3 is 3.33 meter per second square, 10 by 2 is 5 meter per second square. So on 2 kg block, 5 meter per second square in the positive x direction. On 3 kg block, 3.33 meter per second square in the negative x direction.
Yes sir.
Got it or not?
Yes,
Yes
sir.
sir.
This is just after release, okay?
I got this sir, but it's got a doubt whether it's right or not.
You got it? Okay. Next question is, find the elongation in the spring and tension force in the string if the entire system is at rest. Find the elongation in the spring and tension force in the string if the entire system is at rest. Okay?
Yes.
Entire system is at rest. Okay? This
Yes,
entire
sir.
system is at rest. Okay? Rest means, shall I solve this problem?
Yes sir.
For any problem,
Yes,
you need
sir.
to draw what?
Free body diagram.
Free body diagram. Question is asked as, find the tension force in the string. What is the tension force in the string? And the expansion of the extension of the spring. So, the 2m, what are the forces? Tension will be upwards,
2 mg downwards.
2 mg will be downwards. Now, if you keep a system like this, the spring will expand or not?
Yes sir.
The spring is expanded means
Yes, sir.
it will try to compress or not?
Yes sir.
How will be the spring force at this
Yes, sir.
end? Downwards or upwards?
Downwards.
Are you getting?
Downward, sir.
So downwards
Yes.
means, can I
Yes,
write
sir.
it as Fs?
Yes sir.
Varun, did you get it?
Yes, sir.
Next on M block, what is the free body diagram?
Tension.
On M,
There will not be tension
mg.
here. There is no string here. So only spring is there.
Yes sir.
Fs.
Fs upwards,
Fs.
tension upwards, mg downwards.
Tension, where is tension here?
Yes sir. Yes.
There is no
Spring.
string here.
Yes, sir.
I got it.
Mg downwards. So now the block is at rest. That means acceleration is equal to 0. Acceleration is equal to 0.
0.
That means net force should be equal to 0 or not?
Yes sir.
Yes, sir.
E is equal to 2 mg plus Fs. Here Fs is equal to mg. Fs is nothing but what? Here Fs is mg means I'm substituting here. So T is equal to how much? 2 mg
3
plus
mg.
mg.
plus mg.
That is
3 mg.
3
3
mg.
mg. Then another point, tension we got. Spring force is how much? Mg. That implies spring force is how much?
Kx.
Kx.
Yes.
Kx is equal to mg. So x is equal to mg
mg
by
by k.
k. So this is our answer.
Yes, sir.
Yes, sir.
You understood how to solve the problems?
Yes, sir.
Yes, sir.
Hmm? So will you solve another problem?
Yes, sir.
This is a simple problem here. Just try. Have you ever had clarity of spring force?
I just know that spring force is Kx. That's it, sir.
You never solved any problem using spring force.
No, sir.
Okay. It's an easy question. I hope you can solve it.
Yes, sir.
Ten, sir.
You got it?
Yes, sir.
10 or 1 meter? Stick. Draw the free body diagram, right?
1, sir.
Yes,
1.
sir. 1 meter, sir.
1, sir.
Why? If you draw the free body diagram on 10 kg block, there will be spring force in the upward direction, 10g in the downward direction. That if it is at rest, Fs should be equal to 10g, that is 100 newtons. Spring constant is 100, that is kx. 100 into x is 100.
1
X is equal to
100. 1 meter.
1 meter. Answer will be 1 meter. Okay.
Yes, sir.
Now I'll send you another link. Okay.
Yes, sir.